So good afternoon all of you. In last lecture, we have started numericals on theories of elastic failures. Okay. So we have solved two numericals and yesterday I have given three examples for homework. Have you solved these examples or today I will take this? Yes. Snehal, yesterday I have given three examples for solving. Have you solved or today I will take these examples once again?
Yes, ma'am. one एक सॉल्व केले दुसरे नाही सॉल्व झाले.
Okay, so I will take. I think example number one. It's same.
Yes, ma'am.
Okay, so we will take from example number two. Okay, in that I think torque and bending moment is given, right?
Yes, ma'am.
So this is another type. So we will take this type. So please write down numerical.
Hello, ma'am.
Yes.
First, right answer सांगा.
Okay. So yesterday I have given examples in that first question. Okay. So in first question, factor of safety is given. Okay. So you have to use this factor of safety and answers are according to first theory. Okay. Maximum principal stress theory. Answer is 128.94. Should not be less than or equal to 93.33. So structure is unsafe. Okay.
Ma'am 120 असणार ना तिथं.
120.
120 आहे ना तिथं.
हा 120 आहे ma'am.
Okay, so 120. Okay, no problem. Then according to second theory, maximum principal strain theory. Okay, maximum principal strain theory 146.62 should not be less than or equal to 93.33. Okay, got this answer or not? Okay, please check this is correct or incorrect. Yes. Okay. So according to third theory is related to maximum shear stress theory. So according to third theory, answer is 93.94 should not be less than or equal to 46.66. Got this answer or not?
Yes, ma'am.
Okay. Then according to fourth theory, maximum strain energy theory, answer is 24659.28 should not be less than or equal to 8710.18. Structure is not safe again. Have you got this answer or not?
Yes, ma'am.
Okay, and last, according to distortion energy theory, answer is 27699.17 should not be less than or equal to 8710.18. Structure is again not safe. Okay, so these are the final answers for example number 1, which is given for homework. So today we will solve example 2 and 3 because of in this example, I think torque and bending moment is given. So we will solve this example. Okay. So please write down example. At a section of mild steel at a section of mild steel shaft, the maximum torque is 8437 Newton meter. Newton meter. And maximum bending moment is maximum bending moment is 5062.5 Newton meter. Newton meter. Full stop. Determine. Okay, so no. The diameter of shaft is diameter of shaft is 90 mm. 90 mm. And the stress at elastic limit, the stress at elastic limit, the stress at elastic limit is 220 Newton per mm square. Is 220 Newton per mm square. Determine whether the structure is safe or not safe. Safe or not using maximum shear stress theory. Using maximum shear stress theory. Maximum shear stress theory. Okay. So this is the question. In that question, only we have to check the structure is safe or not safe. Only application of one theory, that is maximum shear stress theory. So here we have to apply only one theory, and which is maximum shear stress theory. Okay, so first we will write which parameters are given and then we will solve example. Okay. So here torque and bending moment is given. So torque T which is equal to 8437 Newton meter is given. So we will convert into Newton mm. So into 10 raised to 3 Newton mm. So this is the torque given. After that, next bending moment is given. So M which is equal to 5062.5. Again moment is in Newton meter. So we have to convert into Newton mm. So into 10 raised to 3 Newton mm. Then next diameter of shaft is given. So D which is equal to 90 mm. And next parameter, that is elastic limit. Stress at elastic limit, that is sigma y is given. So sigma y which is equal to 220 Newton per mm square. So that much parameters are given. And here we have to apply maximum shear stress theory. Okay. So second, first we will find maximum shear stress. Find maximum shear stress. Maximum shear stress. Okay. If torque and moment is given, at that time how to find out maximum shear stress? Anyone have remember equation? Tau max which is equal to 16 divided by pi d cube in bracket square root of m square plus t square. Okay. So this equation, by using this equation, first we have to find out maximum shear stress. So if moment and torque is given, so tau max which is equal to 16 divided by pi into d is 90 cube into in bracket square root of moment is 5062.5. 5062.5 into 10 raised to 3 plus torque is 8437 into 10 raised to 3. So we will take this 10 raised to 3 as a common. Okay, we will take this 10 raised to 3 as a common. So we will solve easily. So finally, tau max, which is equal to 16 into 10 raised to 3 divided by pi into 90 cube into in bracket. So what is remaining now? 5062.5 square. So here square is remaining. Here also. Okay, square plus 8437 square. Now you calculate maximum shear and tell me tau max, which is equal to how much? Yes, tau max, which is equal to how much?
Six 8.739.
68.739, that is 74 Newton per mm square. So this is the maximum shear stress. Okay. Now we will apply maximum shear stress theory. Okay. Apply maximum shear stress theory. Shear stress theory. Maximum shear stress theory. So according to maximum shear stress theory, our equation is sigma 1 minus sigma 2 divided by 2 should be less than or equal to sigma y divided by 2 into factor of safety. Okay. So, but in this question, torque and movement is given. So accordingly, we calculated tau max and the value of tau max is 68.74. Okay, now we will check it. This value is less than or equal to sigma y is 220 divided by 2 into factor of safety is 1. So 68.74 should be less than or equal to how much? I think 110, right? 110. So now you tell me, structure is safe or unsafe?
68.74 divided by 2 नाही का घ्यायचं?
No. Suppose principal stresses are given sigma 1 and sigma 2. At that time we will use this equation. But here torque and movement is given. If torque and movement is given, at that time tau max, which is equal to 16 divided by pi d cube in bracket square root of m square plus t square. Okay. And accordingly we have calculated this value. That's why I have written here 68.74. But it
Yes, ma'am.
okay. So now you tell me the structure is safe or unsafe?
Safe.
Okay, so structure is safe. So according to maximum shear stress theory, structure is safe. Okay. Then next we will apply maximum principal stress theory. Okay, we will apply maximum principal stress theory. Okay, in question not asked, but we will apply for our understanding. So next theory, we will apply maximum principal stress theory. So next is step number 3, apply maximum principal stress theory. So according to this theory, sigma 1 should be less than or equal to sigma y divided by factor of safety. So here bending moment and torque is given. So according to this bending moment and torque, first we have to find out sigma 1 and sigma 2. So anyone have remembered how to calculate sigma 1 and sigma 2? If torque and bending moment is given. Which equation is useful here? Anyone? (16 divided by pi d cube in bracket m plus,
M plus under root M square plus.
okay, so m square plus t square. So by using this equation, first we will find out sigma 1 and sigma 2, and then we will apply this maximum principal stress theory. Okay, so we will put values here, sigma 1 comma 2 which is equal to sigma 1 comma 2 which is equal. So whenever we will find out maximum stress, that is sigma 1, so you will take this plus. And whenever you find out this sigma 2, you use this negative sign. Okay, so 16 divided by pi into d is diameter is 90 cube in bracket m. Moment is, again here we will take into 10 raised to 3 common, 10 raised to 3. So moment is 5062.5 plus minus square root of 5062.5 square plus torque is 8437.5 bracket square. So you calculate and tell me sigma 1 which is equal to how much and sigma 2 which is equal to how much.
8437.59.
Sigma 1 how much? Please repeat once again.
Torque तिथे लिहिले ना 8437.5
Ha.
तिथे 0.59
अच्छा अच्छा okay.
स्क्वेअर रूट मध्ये.
Okay, thank you. Now you calculate sigma 1 which is equal to how much and sigma 2 which is equal to how much. Yes, sigma 1 which is equal to how much? (104.11 Newton per mm square). Is correct?
Yes, ma'am.
Okay. Then sigma 2 which is equal to. So whenever you calculate minimum principal stress, at that time equation is same, but instead of this plus sign, you have to consider this minus sign. So accordingly, you calculate and tell me what is the value of sigma 2. Yes, sigma 2 which is equal to how much?
1 minute. Minus 33.38.
Minus 33.30
30.
Newton per mm square. So now we got major principal stress and minor principal stress. Now we will apply maximum principal stress theory. So according to maximum principal stress theory, our equation is sigma 1 should be less than or equal to sigma y divided by factor of safety. So value of sigma 1 is 104.11, should be less than or equal to sigma y is 220 divided by factor of safety is 1. So 104.11 should be less than or equal to 220. should be less than or equal to 220 Newton per mm square. So our structure is safe. Okay, structure is safe. Now we will check for sigma 2. So according to this maximum principal stress theory, mod of sigma 2 should be less than or equal to sigma y divided by factor of safety. So this mod of minus 33.38 should be less than or equal to 220 divided by 1. So mod of minus 33.38 should be less than or equal to 220 Newton per mm square. So our structure is safe. So according to this maximum principal stress theory, the structure is safe. Then we will apply next theory, that is maximum principal strain theory. Apply maximum principal stress theory. Maximum principal strain theory. Maximum principal strain theory. Maximum principal strain theory. So according to this theory, our equation is epsilon 1 should be less than or equal to sigma y divided by factor of safety. So first we have to find out the value of this epsilon 1. So epsilon 1, which is equal to sigma 1 divided by E minus mu into sigma 2 divided by E. Okay, minus mu into sigma 2 divided by E. So epsilon 1, which is equal to sigma 1 already we have calculated, and the value of sigma 1 is 104.11 divided by E minus mu. So we will take here Poisson's ratio 0.3 into our sigma 2 value is minus 33.38 divided by E. So now you calculate the value of epsilon 1 and tell me epsilon 1, which is equal to how much?
One 114.014.
114.014 divided by E. Now we will put this value in above equation. So that is epsilon 1 should be less than or equal to sigma y divided by E into factor of safety. So now we will check here. Okay. So what is our equation? Epsilon 1. So epsilon 1 is 114.014 divided by E should be less than or equal to sigma y is 220 divided by E into factor of safety is 1. So this, suppose E gets cancelled. So 114.014 should be less than or equal to 220 Newton per mm square. So structure is safe. So what it if torque and bending moment is given, so accordingly first you have to calculate maximum shear stress. Okay, maximum shear stress, and then you have to apply maximum shear stress theory. After that, next, whenever if you have to apply principal stress theory, first you calculate principal stresses by using equation of movement and torque. Okay, once you got sigma 1 and sigma 2, then you are able to apply maximum principal stress theory. After that, suppose you have to apply maximum principal strain theory. So first you have to calculate epsilon 1 value. And how to calculate this epsilon 1? Epsilon 1, which is equal to sigma 1 upon E minus mu into sigma 2 upon E. Once you get value of epsilon 1, then you are able to apply maximum principal strain theory. Okay, so please write down fast. We will take next example. If your writing is over, shall I take next example? Yes.
Yes, ma'am.
Okay. So please write down next example. A circular bar is is withstand withstand bending moment of bending moment of bending moment of bending moment of 10 kilonewton meter 10 kilonewton meter and torque of and torque of 2 kilonewton meter 2 kilonewton meter full stop determine 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 diameter of bar determine diameter of bar diameter of bar determine diameter of bar if yield stress yield stress is if yield stress is 250 MPa 250 MPa and factor of safety is 1.5 factor of safety is 1.5 to stop use maximum maximum shear stress theory maximum stress theory shear stress theory maximum shear stress theory and maximum principal strain theory maximum principal strain theory maximum principal strain theory maximum principal strain theory. So here we have to find out diameter. Okay, we have to find out diameter by applying maximum shear stress theory and maximum principal strain theory. So first we will write given parameters and then we'll apply theories. So our step number 1, given parameters. So similarly here bending moment, that is M is given, M which is equal to 10 kilonewton meter. So we will convert into Newton mm. We will convert into Newton mm. So 10 into 10 raised to 6. How comes 10 raised to 6? 10 into 10 raised to 3 for kilonewton to Newton and 10 raised to 3 for meter to mm. So 3 plus 3, that is 6. So 10 into 10 raised to 6 Newton mm. Okay. After that, next parameter, that is torque is given. So T which is equal to 2 kilonewton meter. Okay. Again we have to convert it. So 2 into 10 raised to 6 Newton mm. Okay. The next yield stress is given, that is sigma y. So sigma y which is equal to 250 Newton per mm square. 250 Newton per mm square. Factor of safety is given. Factor of safety which is equal to 1.5. And in question, please write down. Take mu which is equal to take mu which is equal to 0.3. So value of Poisson's ratio mu is given 0.3. Okay, 0.3. And which parameter we have to find out by application of maximum shear stress theory and maximum principal strain theory? So in this question, we have to find out diameter. So D, which is equal to question mark. D, which is equal to question mark. So step number 3, use maximum shear stress theory. Shear stress theory. Shear stress theory. Maximum shear stress theory. So according to maximum shear stress theory, our equation is sigma 1 minus sigma 2 divided by 2 should be less than or equal to sigma y divided by 2 into factor of safety. But here torque and bending moments are given. So we have to apply equation related to torque and bending moment. Okay. So anyone please unmute and tell me which equation here applicable. Instead of this sigma 1 minus sigma 2 divided by 2, which equation we will apply here? Tau max should be less than or equal to sigma y divided by 2 into factor of safety. So if torque and bending moment is given, then tau max is 16 divided by pi d cube into in bracket square root of m square plus t square, okay, which is equal to sigma y divided by 2 into factor of safety. Now we will put values here. So 16 divided by pi d cube as it is, because of we have to find out diameter, into, so under root of, in m and t, 10 raised to 6 is there. So we will take this 10 raised to 6 as a common. So 16 into 10 raised to 6 in bracket. So what is remaining in bracket? 10 square plus torque is 2 square. So you calculate, which is equal to sigma y. Sigma y is 250 divided by 2 into 1.5. Okay, so now we will convert this equation. Okay, so this, first you calculate this, square root of 10 square plus 2 square is how much? 16 into 10 raised to 6 divided by pi d cube into, what is the value of this 10 square plus 2 square? Yes,
10.19.
1.
9.
Okay, 10.19, which is equal to 250 divided by 2 into 1.5. So now we will shift this d cube to right side. So 16 into 10 raised to 6 into 10.19 into. Now this 2 into 1.5 is at denominator. When we will shift to left side, it will go at numerator. So 2 into 1.5 divided by pi as it is into 250. So this d cube shift at numerator. So d cube. So you calculate the value of d cube and tell me d cube which is equal to how much? Yes, d cube which is equal to how much? Yes, anyone? Someone has written chat box. 622791. Please check once again. Near about same, but please check once again. So as per your calculation, d cube which is equal to 6 2, yes, 6 2 6 2 2 7 2 7.
623255.
Yes, someone has, yes, this is correct. 6 2 3 2 3 2 5 5.85 is correct. Okay. So d cube which is equal to 623255.85. Now d which is equal to 85.42 mm. Am I right?
Yes, ma'am.
So d which is equal to 85.42 mm. So according to maximum principal stress theory, we got the value of diameter which is equal to 85.42 mm. Now we will check by using maximum principal strain theory. Okay, so we will apply maximum principal strain theory. So next step is use maximum principal strain theory. So according to this theory, our equation is epsilon 1 should be less than or equal to sigma y divided by E into factor of safety. So first we will find out epsilon 1. So epsilon 1 which is equal to sigma 1 divided by E minus mu into sigma 2 divided by E. So here sigma 1 and sigma 2 are unknown. First we will find out this sigma 1 and sigma 2. So if bending moment and torque is given, then sigma 1 sigma 2 which is equal to 16 divided by pi d cube in bracket m plus minus under root of m square plus t square. Okay. So we will put values here. So sigma 1 comma sigma 2 which is equal to 16 divided by 16 divided by pi d cube in bracket m, the value of here again we will take 10 raised to 6 common. So m is 10 plus minus square root of 10 square plus 2 square. So now you tell me the value of sigma 1 in terms of d cube. Okay. And sigma 2 in terms of d cube. So because of this d cube is unknown. Yes, sigma 1 which is equal to how much? Okay, 102.86 into 10 raised to 6 divided by d cube is correct answer. Okay. So sigma 1 which is equal to 102.86 into 10 raised to 6 divided by d cube. Now you tell me sigma 2 which is equal to how much? Sigma 2 in terms of d cube. So sigma 2 which is equal to, yes, sigma 2 which is equal to minus 1 into 10 raised to 6. Okay, good. So minus 1.00 into 10 raised to 6 divided by d cube. Now here sigma 1 and sigma 2 values are with you. So we will put in epsilon equation. So epsilon 1 which is equal to sigma 1. So sigma 1 is 102.86 into 10 raised to 6 divided by d cube into e. Okay, then minus 0.3 into sigma 2 is minus 1.00 into 10 raised to 6 divided by d cube into e. So d cube into e we will take common. So epsilon 1 which is equal to 102.86 into 10 raised to 6 minus 0.3 into minus 1.00 into 10 raised to 6 divided by d cube into e. So you calculate and tell me epsilon 1 which is equal to how much? So this minus minus gets plus, and finally epsilon 1 which is equal to how much? 103.16 into 10 raised to 6 into 10 raised to 6 divided by d cube into e. So someone has, okay, 103.16 into 10 raised to 6 divided by d cube into e. Now we will put this epsilon value in maximum principal strain theory. So our basic equation is epsilon 1 should be less than or equal to sigma y divided by e into factor of safety. So epsilon 1 is 103.16 into 10 raised to 6 divided by d cube into e should be less than or equal to, fact yield stress 250 divided by e into factor of safety is 1.5. So this e and e gets cancelled. Okay, so 1.3, sorry, 103.16 into 10 raised to 6. Now this 1.5 we will shift here numerator, 1.5 divided by 250, okay, which is equal to d cube. So you calculate the value of d and tell me d which is equal to how much? reply 85.22. Good, correct answer. So D, which is equal to 85.22 mm. So according to maximum principal stress theory, diameter is 85.42. And according to maximum principal strain theory, diameter is 85.22. So we got same diameter. Okay. If anybody having any doubt, ask me. Otherwise, please write down. So we will take next example. Okay. Write down fast. Okay, completed.
Yes.
Okay, so we'll take next example. Please write down next example. A circular rod, a circular rod circular rod is withstand withstand bending moment of bending withstand bending moment of bending a moment of 30 kilonewton meter 30 kilonewton meter and and torque of 25 kilonewton meter 25 kilonewton meter torque of 25 kilonewton meter full stop determine 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 the diameter of the bar determine the diameter of the bar determine the diameter of the bar diameter of the bar if if yield stress if yield stress of yield stress of material is yield stress of material is yield stress of material is 250 MPa 250 MPa and factor of safety is 2 2 use maximum shear stress theory maximum shear stress theory use maximum shear stress theory. So here we have to apply only maximum shear stress theory. So first we will write given parameters and then we will solve problem. Okay. So first given. You unmute and tell me which parameters are given.
Bending 30 kilonewton meter.
30 kilonewton meter. So we have to convert into Newton mm. So how to convert?
30 into 10 raised to 6 Newton mm.
Okay, good. 30 into 10 raised to 6 Newton mm. Then next parameter.
Torque
Torque. T which is equal to
25 into 10 raised to 6 into Newton mm.
okay 10 raised to 6 Newton mm. Then next
Yield stress sigma y is equal to 250 megapascal.
okay so sigma y that is yield stress is given. So sigma y which is equal to 250 MPa means Newton per mm square is given. Then next
Factor of safety is equal to 2.
okay factor of safety which is equal to 2 and which parameter we have to find out?
Diameter
Okay, good. So diameter of circular rod we have to find out. So D which is equal to question mark. D which is equal to question mark. So in this question, we have to use maximum shear stress theory. Use maximum shear stress theory. Maximum shear stress theory. So according to maximum shear stress theory, our equation is sigma 1 minus sigma 2 divided by 2 should be less than or equal to sigma y divided by 2 into factor of safety. So this is the basic equation. But again in this question, torque and bending moment is given. So we will apply equation related to torque and bending moment. Okay. So whenever torque and bending moment is given, then the equation is tau max should be less than or equal to sigma y divided by 2 into factor of safety. And tau max, the equation of this tau max is 16 divided by pi d cube into, in bracket, under root of m square plus t square should be less than or equal to, okay, should be less than or equal to sigma y divided by 2 into factor of safety. So now we will put values here. So 16 divided by pi into d cube as it is into, okay, square root of m square, that is 30 into 10 raised to 6 plus 25 into, okay, 10 raised to 6 bracket square plus 25 into 10 raised to 6 bracket square. Okay, should be less than or equal to sigma y is 250 divided by 2 into factor of safety is 2. Okay, so we will take 10 raised to 6 common. So 16 into 10 raised to 6 and we will rearrange this equation. So into 2 into 2 into this equation. So square root of 30 square plus 25 square. Okay, 25 square divided by pi into 250, which is equal to d cube. So you calculate diameter and tell me d, which is equal to how much. First you calculate d cube and then tell me d, which is equal to. So d cube, which is equal to, and then last diameter, which is equal. Yes. Chat box. 3 1 d cube, which is equal to 31820802.7 mm, and finally d, which is equal to, therefore diameter, which is equal to 147.08 mm. Good, correct answer, 147.08 mm. Now you have understood how to find out diameter if torque and bending moment is given. Okay, so please write down. Then we will solve last example on this unit and then we will conclude this unit. So please write down fast.
1.
Okay, if your writing is over, shall I take next example? Yes, anyone?
Yes, ma'am.
So now we will take last example on this unit number 4 and then we will continue. So please write down last example. A bolt is a bolt is subjected to subjected to subjected to an axial tensile force and axial tensile force tensile axial tensile force of 18 kilonewton of 18 kilonewton accompanied by accompanied by transverse shear force accompanied by transverse shear force transverse shear force transverse shear force of 18 kilonewton transverse shear force of 9 kilonewton of 9 kilonewton full stop elastic limit in tension elastic limit in tension elastic limit in tension 2 to 5 Newton per mm square. Factor of safety is 3. Factor of safety is 3 and factor of safety is 3 and Poisson's ratio is Poisson's Poisson's ratio Poisson's ratio is 0.3 0.3 Poisson's ratio is 0.3. Find the diameter of bolt. Find the diameter of bolt. Diameter of bolt using maximum shear stress theory. Maximum shear stress theory. Maximum shear stress theory. So here again we have to find out diameter of bolt, but here directly values are not given. So first we have to find out normal stress, then shear stress, then we will find out principal stresses, and then we will apply maximum shear stress theory. Okay, so this problem is difficult. So first we will write given parameters and then we will solve problem. So here force is given, axial force is given. So P which is equal to 18 kilonewton. Then shear force is given. Okay, shear force is given. Shear force which is equal to 9 kilonewton. Next, elastic limit, that is yield stress, is given 225 Newton per mm square. Next parameter is factor of safety which is equal to 3 given. Poisson's ratio mu is 0.3. Okay. And we have to find out the diameter of rod. So Only one parameter we have to find out, and this parameter is diameter, which is equal to question mark. So first we will find out normal stress. Find normal stress. Find normal stress. So normal stress is denoted by using sigma. So sigma, which is equal to sigma x, which is equal to, how to find out normal stress? Yes, how to find out normal stress? Anyone? If load is given,
Force per unit area.
force per unit area, but here diameter is not given, so we will find out stress in terms of diameter. Okay, so force divided by area, so which is equal to, force is 18 into 10 raised to 3 divided by area is pi by 4 into d square. So we will find out stress in terms of d square. So you calculate and tell me sigma x, which is equal to how much in terms of d square? Sigma x, which is equal to how much? D square in terms of d square. Yes, sigma x, which is equal to, so sigma x, which is equal to 22.918 into 10 raised to 3 divided by d square. Okay, so 22.98. Good, correct answer. And here sigma y, which is equal to 0. Okay, sigma y, which is equal to 0. Next we will find out shear stress. Okay, we will find out shear stress. Find shear stress. Find shear stress. So for finding out the shear stress, shear force is given. Okay, so shear stress tau, which is equal to force upon area. So again here same, force is 9 into 10 raised to 3 divided by area is pi by 4 into d square. So here again you calculate shear force tau, which is equal to in terms of d square. Think answer is half of this because of force is half of this. No? So shear stress, which is equal to 11.46 into 10 raised to 3. 10 raised to 3 divided by d square divided by d square Newton per mm square. Now you observe here sigma x, sigma y already we have calculated, and tau we have calculated. So next step is we will calculate principal stresses. Find principal stresses. Find principal stresses. So if sigma x, y and tau is given, at that time how to find out principal stresses? Sigma 1 comma sigma 2, which is equal to sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 bracket square plus tau square. Okay. So sigma 1 comma sigma 2 which is equal to sigma x. So from that sigma x and tau square, we will take 10 raised to 3 and d square common. So 10 raised to 3 divided by d square we will take common. So now in bracket, the value of sigma x is 22.918. Okay. Plus sigma y is 0 divided by 2 plus minus square root of, here again same, 22.918 minus 0 divided by 2 bracket square plus the value of tau is 11.46 bracket square. So from this sigma x and tau square value, I have taken 10 raised to 3 divided by d square as a common. Okay. So you calculate value of sigma 1 and sigma 2 in terms of d square and then tell me. Sigma 1 which is equal to how much? Sigma 2 which is equal to how much? Okay, someone give a reply, but I think sigma 1 which is equal to 27.64 into 10 raised to 3 divided by d square. Okay, Newton per mm square. And sigma 2 which is equal to minus 4.749 into 10 raised to 3 divided by d square Newton per mm square. So these are the values of sigma 1 and sigma 2. Yes, 27.65. Yes, correct answer. Okay, so once we got sigma 1 and sigma 2, then we will apply maximum shear stress theory. Okay, so next step is we will apply use maximum shear stress theory. Maximum shear stress theory. Shear stress theory. So how to use this theory? So according to maximum shear stress theory, sigma 1 minus sigma 2 divided by 2 should be less than or equal to sigma y divided by 2 into factor of safety. So sigma 1 is 27.64 into 10 raised to 3 divided by d square minus sigma 2 is, so this 2 gets cancelled, okay, minus sigma 2 is how much? Sigma 2 minus, I will write here, minus 4.749 into 10 raised to 3 divided by d square, okay, which is equal to sigma y is 225 divided by this 2 and 2 gets cancelled. So only a factor of safety is remaining 3, okay. So you calculate likewise 27.64 into 10 raised to 3. So this minus minus gets plus 4.749 into 10 raised to 3 divided by d square, which is equal to 225.3. Okay. Then you shift this 3 to numerator and this 225 to denominator. So 27.64 into 10 raised to 3 plus 4.749 into 10 raised to 3 into 3 divided by 225, which is equal to d square, and finally d, which is equal to how much? D 20.78, good, correct answer. So D, which is equal to 20.78, 20.78 mm. So this is the final answer. Okay. So first you have to read problem carefully. In that, which parameters are given and which parameters you have to find out. Okay. So accordingly, you have to use steps. Okay. If you have doubt, ask me. Otherwise, please write down. So we will summarize this unit number 4. Please write down.
Complete, ma'am.
Okay, your writing is over. Yes. Okay, so we will take last point. Please note down this last point is most important. Important points. Important points. Important points from theories of failure. Important points from theories of failure. Theories of failures. Theories of failures used in design. Used in design. Used in design. So now we will discuss important points from theories of failure. Okay, so already we have discussed there are total 5 theories. So accordingly now we will discuss important points. Okay, so first you write, then I will explain. So the cause of failure of a material, the cause of failure of material, failure of material, the cause of failure of material depends not only material depends not only depends not only on the properties of on the properties of on the properties of on the properties of the material on the properties of the material properties of the material but also but also but also the stress system but also the stress system but also the stress system to which it is subjected to which it is subjected to which it is subjected to which it is subjected. Okay, so from this sentence you understood the cause of failure of material. So material failure is not only depend on properties of material, but also it is depend on stress system which it is subjected. Means material failure is not depend on properties of material. It also depend on which type of stress system is occurred. Okay. So now the next point is the various theories of failure, the various theories of failure, theories of failure, the various theories of failure, various theories of failure, and its applicability, its applicability, its applicability, its applicability can be understood by can be understood by can be understood by following points understood by following points. So already you know that there are 5 theories of elastic failures. Okay, and their applicability we will understood by following points. So write down first point in that. First point, The maximum principal stress theory, the maximum principal stress theory, maximum principal stress theory, maximum principal stress theory should be used, should be used, should be used, should be used in case of, in case of, should be used in case of brittle materials, in case of brittle materials, brittle materials should be used in case of brittle materials such as cast irons, such as cast irons, such as cast irons, such as cast iron. Okay, so this is the first point. In that point, maximum principal stress theory. So this maximum principal stress theory is used for brittle materials. Okay, you remember that for brittle material, maximum principal stress theory is used. Okay, then we will write second point. Second point is the maximum shear stress or the maximum shear stress, maximum shear stress, maximum shear stress or maximum shear strain energy, maximum shear strain energy, maximum shear strain energy, maximum shear strain energy theory should be used for, should be used for, should be used for, should be used for ductile material, should be used for ductile material, should be used for ductile material. Full stop. These theories gives, these theories, these theories gives a good, these theories gives a good, these theories gives a good approximation, these theories gives a good approximation when the mean principal, when the mean principal stress is, mean principal stress is, mean principal stress is compressive, mean principal stress is compressive, stress is compressive. The shear strain energy should be preferred, compressive. The shear strain energy, shear strain energy, shear strain energy should be preferred. Okay, this is second point. First you write down, then I will explain. The next third point. Third point is the maximum strain theory. The maximum strain theory, maximum strain theory gives, maximum strain theory gives reliable result, reliable results in particular, in particular cases, in particular cases. Hence this theory, hence this theory, hence this theory should not be used in general. This theory should not be used in general, not be used in general, fracture. And last point, the maximum shear stress theory, the maximum shear stress theory, maximum shear stress theory, maximum shear stress theory should not be applied, should not be applied, should not be applied, should not be applied in case, in the case, in the case where the, in the case where the state of stress, where the state of stress, where the state of stress consists of, consists of, consists of triaxial, triaxial tensile stress, triaxial tensile stress, triaxial tensile stress of nearly equal magnitude, stress of nearly equal, nearly equal magnitude, nearly equal magnitude, nearly equal magnitude, reducing, reducing the shearing stress, reducing the shearing stress, reducing the shearing stress to a small magnitude, shearing stress to a small magnitude, to a small magnitude, small magnitude. Full stop. In this case, in this case, in this case, the failure would be, the failure would be, the failure would be brittle, failure would be brittle fracture, brittle fracture rather than, rather than by yielding, rather by, rather than by yielding, rather than by yielding. So you finish right up, I will explain. Okay, so these are the important points from theories of failure. Okay, so just you have to remember that the failure of material does not depend only properties of material, but it also depend on the stress system which is subjective. Okay, and 3-4 points you have to remember from these theories. Okay, so in that first point is maximum stress theory, is useful for brittle materials. Okay, so you remember maximum principal stress theory is used for brittle materials. Okay, then next point is maximum shear stress or maximum shear strain energy theory is useful for ductile material. Okay, so for ductile material, we will use maximum shear stress or maximum shear strain energy theory. And then next third point is maximum strain theory gives reliable results in particular cases. Hence, this theory should not be used in general. So if we use this maximum strain energy theory, so according to this theory, you will get reliable results, okay, in particular cases. That's why this theory is not generally used. And last one is the maximum shear stress theory should not be applied in case where the state of stress consists of triaxial tensile stresses. Okay. So if triaxial tensile stresses are applied, at that time this maximum shear stress theory is not useful. Okay. And in case of failure would be brittle fracture rather than by yielding. So here fracture is brittle fracture instead of yielding. So these are the points you have to remember from theories of failure. Okay. So now our unit number 4 is over. So in this unit number 4, we have discussed a total 5 theories. First theory is maximum principal stress theory, and this theory was developed by maximum principal stress theory is developed by, yes, maximum principal stress theory. Maximum principal stress theory was developed by, yes, please unmute and tell me. You have to remember that because of a lot of MCQ will be asked on this unit. So maximum principal stress theory was developed by Rankine. Okay, Rankine. Then second theory is maximum principal strain theory. Maximum principal strain theory. Now you tell me this theory was developed by, yes, this theory was developed by Saint Venant. Okay, Saint Venant scientist. Saint Venant scientist. Then third theory is maximum shear stress theory. Maximum shear stress theory. Maximum shear stress theory. Okay, maximum shear stress theory. This theory was developed by Gust and Tresca. This theory was developed by Gust and Tresca. So this theory is called as Gust theory. So this theory is called as Gust theory. Okay, so you remember this point also. The next theory number 4. Fourth theory is related to maximum strain energy theory. Maximum strain energy theory. Maximum strain energy theory. Maximum strain energy theory. And this theory was developed by Hay. This theory was developed by Hay. So this theory is called as Hay's theory. Okay, this theory is called as Hay's theory. And last, fifth theory, that is maximum shear strain energy theory. Maximum shear strain energy theory. Maximum shear strain energy theory. Maximum shear strain energy theory, or this is also called as distortion theory. Distortion energy theory. Distortion energy theory. And this theory was developed by Mises and Henke. This theory was developed by Mises and Henke. So this theory is called as Mises-Henke theory. Mises and Henke. So this theory is called as Mises and Mises-Henke theory. Mises-Henke theory. Mises-Henke theory. So you just remember, because of on this point, maybe 1 or 2 MCQ will be asked. Okay. So now our unit number 4 is over. In next lecture, we will start unit number 5, that is section second. Okay. So in that section second, unit number 5 is related to shear stress and bending moment diagram. So I request all of you, please attend lectures continuously from next lecture. Okay, thank you. So today we will stop here.